Okay, so topic 3 is going to be pretty quick. We're doing a sinusoidal regression. So it's very much the same skills we use for polynomial function regressions. But now we're going to answer questions about sinusoidal functions. So, information. We're looking at our scatter plots, which is a set of point-on grids. We've done that before. And we've used this to visualize a trend in the data. And a sinusoidal regression is the equation of the curve of best fit when the scatter plot looks like a sinusoidal function. In this case, technology uses that sinusoidal regression to determine the equation that balances the points in the scatter plots on both sides of the curve. Now, we primarily considered sinusoidal functions written in the form y is equal to a sine bx plus c plus d, and the calculator generates the regression equation of the same form. So calculator's technology is going to do some work for us here. So let's take a look. So we've got an example here, and we're going to see how we use it. In 2001, the Singapore Flyer was the largest Ferris wheel in the world. The table below gives the height of a rider from the ground at different times. So we've got this familiar table of values. So we're going to follow our instructions, and as you notice, they are at the back of this book as well, except now there's another selection for sinusoidal regression. So this is on page 49 of this booklet. You're going to walk through those progressions with your calculator, so I'll kind of walk through it. So we're going to take that data. First thing we do, we're going to put our diagnostic on. It's not so critical for this right now. Clear all your equations out of y1. So just make sure you've got no other equations in there. Go into your lists. So hit Stat, Enter. Highlight your lists, L2 and L1, and clear them out so that they're clear, right? Once that's all cleared, then you're going to take this chart here, and you're going to enter this data in, just like we've done a million times with linear regressions, quadratic regressions, and cubic regressions. Once that data's in, you can turn stat plot on, because you want that on so that you can plot the scatter plot. And then, so go second function y equals, that's stat plot. And we want to turn stat plot on, enter, enter. Make sure your lists are L1 and L2 for X and Y. And then adjust the window. We'll let the calculator do it for you. So hit zoom, 9, and then it'll graph your scatter plot. If you need to, you can go and adjust those windows, but I did on mine, worked perfectly. Okay, then graph it. You can already see when you graph it that you have this nice scatter plot, because you're going to get this graph, and you get dun, 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 right? Like it's textbook. You can see, oh, that's a sinusoidal function, because it even looks like it, right? Then you're going to do your regression. So now, hit Stat and arrow over to Calc. And now you can see you're going to select C. So you might have to arrow down to find C, or so that you can choose it, because you have to arrow down quite a bit. But find C for your choice, and it'll even say sine reg, right? And then you can put in second function 1, comma, second function 2 for your data in list 1 and list 2, and press enter. And you're going to get your sinusoidal regression. Now that you have that, we want all the parameters that you've located. So you should get A is equal to 246, B is equal to 0.1698, and it says round to the hundreds, so we can say 0.17. C is equal to negative 15707. We'll round that to negative 157. And D is equal to 295. Okay? From that, you can use VAR's VAR's 5 arrow to put it into your y equals, and then graph and see what that looks like. And you're going to want to do that because it's going to help you answer the rest of the questions. Okay? But you use those to write your equation. So our equation from these would be y equals 246 for A, sine brackets 0.17x minus 1.57, which is our C, plus 295. That is our regression equation. Now, find the period. So our period is 2 pi over b. Please note, remember to use radian mode when we're performing sinusoidal regression unless the x value represents an angle measure in degrees. So here it doesn't. The x value equals time, so you're going to do it in radians. So make sure your mode is in radians. And if you didn't, that might be why you have some issues. But you should assume that it's in radians. Okay? So we calculate this, and we get for a value, you can either write 11.76 pi, or if I calculate that out right, I get 36.96 minutes, or 37 minutes. What does that mean? Well, that's the time for one rotation, right? One time, because it's max to max, right? So from the top, we go back to the bottom, and then we go back up to the top. So basically, we've done one rotation. Remember that if we're looking at this, we're going up, up, up. We're going from this point to this point. That's the period, right? How high off the ground is the center of the Singapore Flyer? Well, if we're looking for the center, then we're looking for the midline, right? What's in the middle? So D equals our midline, which is equal to 295 feet. Okay? So that's your middle position, right? Jared rode the Singapore Flyer for 2 consecutive rotations. His friend Luke was in a building across from the ride at a height of 400 feet. When was Jared first level with Luke, rounded to the nearest tenth? So you're going to want to, on your calculator, in addition to having your regression equation in there, you're going to, for y2, you're going to make it equal to 400, because that will be 400 feet. And then you're going to do intersection. Okay, so use your intersection. Make sure, because 400 is going to cross that curve several times, that what you want is you want the first intersection. So make sure you're putting your 2 points that you're looking at close to that first intersection. When you do that, you're going to get x is equal to 11.9 minutes. And you probably could even round that to 12 minutes. Okay? At what time was Jared at a height of 500 meters for the second time to the nearest tenth? So same thing as the last one, except here you'll make y2 equal to 500 and use intersection. But you want the second intersection. So again, watch for that. And I got 21.9 minutes, okay, for my x. At what height was Jared at 22 minutes to the nearest tenth? Well, he wasn't still at 500 feet. He was at 498.8 feet. And what I did is I used value, and I got and put in x equals 22, and that gave me my answer of 498 feet. So second function, trace one value, and you put in 22. And as you can see, at that point, Jared is starting to, he's going down, because it's the second time he was at 500. The first time was when he was going up. Second time is when he's going down. So he's gone down just a couple of feet after that 21.9 minutes. Okay, so as you can see, you can use these regressions to answer questions. A sinusoidal regression looks a lot like a I mean, the process is on your calculator, same as linear regression, quadratic regression, or cubic regression, except now you're looking at a sinusoidal function. And you really just have to think about what does each thing mean. Assume that you're in radians unless your x values actually are degrees, because sometimes they are. And if something's not working, like you're putting it in and you're getting a flat line, try switching from degrees to radians or radians to degree and see if that fixes what you're looking at. That's just a general troubleshooting tactic, okay? But we're doing the same thing we did with the other ones. Now, use radian mode. The graphing calculator is going to do a lot of your work for you. And a sinusoidal curve of best fit can be used to predict values that are not recorded. So interpolation or extrapolation. The three we did on the example were all interpolation. But you might actually need to extrapolate. Remember, you can always change the window if you need to. And I'll tell you right now, with sinusoidal regressions, you're only going to need to change your x values. Because if it's sinusoidal and you've got the max and min of your curve, then the y values are not going to change. They're not going to get bigger or smaller. So you just need to extend your x values. Okay? So a lot of this is now applications and practice. We should be old hands at this because we've done so many regressions. And now you can take the time